Today I demonstrate one important theorem in measure theory. While all familiar this theorem, and obviously this one is crucial and important theorem in measure theory. Okay, we start about Radon Nykodym theorem. Okay, Radon Nykodym theorem. So we start it now. Here, Radon Nykodym theorem. Okay, so what it says about that, we know about, we just demonstrate. Okay, not we done it the proper way. What here, mu comma b sigma finite measure. Okay, sigma finite measures means what? Sigma finite measure means we know about that some set, this one is union of n equal to 1 to infinity a n, then mu of a n less than plus infinity, and gamma of a n less than plus infinity. We also know about that, yes or no? I think yes. So we erase that portion. And one, obviously this one is in a measure space. Okay, in a measurable space or measure space, this x gift a. And next one, gamma is absolutely continuous with respect to mu, means similar if gamma of e equal to 0 implies that mu of e equal to 0 implies that gamma of e equal to 0 for e belongs to this algebra. Okay, I think this one is absolutely continuous. Is that means absolutely continuous definition is this one. Okay, is any problem here? I think not a problem at all. Okay, if sign measure, if here if finite measure, then not a problem. If this one sign measure, then here total variation is needed. Okay, but this one is not here needed because this one is finite measure. So what happened, these two options are given. This one is what options given, that means if this one is the, that means one part of Radon Nykodym theorem, those parts radon are considered. Okay, that means considerable part is this two. And what we obtain now, then what we obtain, then there exists, okay, there exists a measurable function. Measurable function, we know about that, I think. If this one x to 0 plus infinity, okay, that means measurable real valued function, obviously positive valued function, and obviously positive and 0 valued occurred. Okay, function, then what we obtain, we also known that this gamma e, okay, this gamma e equal to integration of e f d mu. That means this we get a function. Okay, we get a measurable, obviously real valued, positive real valued with 0 valued function. Okay, and obviously this value, this functions integration with respect to d mu equal to d gamma. Are you understand about that Radon Nykodym theorem? So radon are considered these two options and obviously develop this one. Okay, so no, this means obviously again here if be unique. Okay, that means there exists a measurable function, unique measurable function. Okay, if unique is not here, we write here a unique or an unique measurable function, then this one is better. I understand about this Radon Nykodym theorem, that means what is considerable part or given that, and what is considerable part. Okay, Radon are considered those ones, and obviously what is the conclusion part, this one. Okay, this one Radon shows that. So how we proceed, the proof of Radon Nykodym theorem, we erase that portion. Okay, we erase that portion and going to proceed how to proceed this proof. First we let mu and gamma be finite measure. Finite measure means we know about, obviously, that means mu of x and gamma of x less than this one, mu of x less than plus infinity and gamma of x less than plus infinity. Okay, so next what we construct one f. This is the collection of those functions which are similar x to 0 plus infinity and such that what these functions have, that means f measurable functions. This one is first needed, measurable function, and obviously second need is integration of e f t mu. Okay, this one, integration of e f t mu less than here gamma of e. Okay, this one is needed condition. Sorry, here less than equal to. Okay, less than equal to this one. Here e belongs to this algebra. So this one we construct. Now what we do that this f, this collection f, this f coming from this collection satisfies those property. That means integrable with respect to measure t mu obviously less than equal to what? Less than equal to some measure of earth. That means some set of measure here with respect to this set and then some set of another measure. Okay, then some measure, that means measure of this set, sorry, set of another measure, not measure of this set. Okay, that means integration of f t mu obviously less than equal to, with respect to e, obviously less than equal to, and that means another measure of this set e. Okay, so this one is too easily done. That means here we also how we that means conclude this part, because in conclusion part this one is needed. Okay, this one is needed in conclusion part. That means measure of this set obviously equal to some integration of f with respect to another measure and obviously in e, this set. So this one is the conclusion part, and this one we have to prove this theorem, then we take this one. Okay, so what we now, how we proceed further? We proceed further, we also take this one, this integration t mu supremum of, here what is needed, that means a belongs to this collection. Okay, this, that means we integration of f d mu obviously this part. Okay, this part supremum equal to alpha. Okay, and supremum of f belongs to f, this one equal to alpha. So what happened now, then we also going to further discussion of that. Obviously we take what, we take alpha equal to limit n tending to infinity fn x. Okay, where integration of, sorry, fn d mu f. Okay, with respect to x, that means this one integration equal to alpha. Why? Because this one supremum of this equal to alpha. That means if we take fn in f, fn in this collection f, then this one happened. Okay, and obviously this collection is not equal to 0 first, because we know about that if f equal to 0 then satisfies this condition. Okay, this condition is satisfied, so we talk about that. Okay, so now we're going to be another way. Okay, we erase that portion and another way is here. Then this one is done. Then we think about that here, that means A be a and another set, B another set. Okay, then this set is divisible by in this way. Here A1 x, okay, x belongs to this A such that f1 x greater than f2 x, and A2 here x belongs to those A such that f1 x less than equal to f2 x. Okay, then what happened? Then we also see about that this A1 and A2, okay, are measurable subset of A, measurable subsets of A. And what happened? And A equal to A1 union A2 and A1 intersection A2 equal to 5. Okay, that means disjoint union. Then another one, then we proceed further. Okay, how we proceed further? We take about that this one, maximum of f1 f2. Okay, what we see that this one less than equal to gamma A. Okay, this one is too easily we done it. Okay, just A1 here, A1 A2, then gamma A1 gamma A2 less than equal to, then this one is obviously gamma A. Okay, so we done it. And another way we also considered what? Then we considered further maximum of those f1 f2 dot 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 fn. Okay, this one obviously belongs to this f, and obviously belongs to this f means this one are obviously less than equal to gamma A. Okay, that means we have to prove that. Then what we that means how we proceed? We erase our portion and going to further discussion of that. Then how we proceed? We also see that gn equal to that. Okay, gnx equal to maximum of f1x f2x dot 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 fnx. Then what we do? We do that we see gn be monotonically increasing sequence. Okay, and monotonically increasing sequence, and obviously then we find another g equal to supremum of gnx. Okay, sorry, supremum of here fnx. Okay, and n belongs to this natural number and x belongs to this x. Okay, then what happened? That means gn is converges to g. Okay, pointwise converges to the measurable function g, and obviously then g d mu. Okay, by monotone convergence theorem, but here pointwise. Okay, and by monotone convergence theorem. Okay, what happened? Eg d mu, that means limit is outside. Okay, limit is inside. Limit n tending to infinity gn d mu equal to what? Limit n tending to infinity e gn d mu. Okay, by monotone convergence theorem. Then this one equal to what? We know about that gn d mu less than equal to gamma e. Okay, and then this one obviously less than equal to gamma e. Then what happened? Then g belongs to this f. Okay, that means we also see that gn belongs to this f. We construct and we assume that portion, and then we going to gn equal converts to pointwise g. Then by here we write monotone convergence theorem. Okay, monotone convergence theorem, this one happened. Okay, g belongs to f. Then g belongs to f. Why? Because this one is less than equal to gamma e. Okay, then what we get? We get this one integration of here x g d mu less than equal to alpha. Okay, because we know about that alpha is the supremum of these functions. Okay, then again we also see about that. We erase that portion and going to further discussion of that. What happened is here this one, that means we know about that alpha equal to limit n tending to infinity integration of x fn d mu. Okay, this one is alpha, and obviously fn subset of less than equal to gn, because we know about that gn equal to maximum of that. Then what happened, then this one implies that integration of fn d mu less than equal to gn d mu here e. Okay, then this one here x we construct. Then what happened, then this one equal to alpha equal to integration of x fn d mu and limit n tending to infinity less than equal to limit n tending to infinity x gn d mu. Okay, then what happened, then this one equal to g d mu with respect to x, and so we get integration of x g d mu equal to alpha. Okay, so we see about that. We also get this one. Okay, integration of g d mu x with respect to x equal to alpha. Now we have to show that what, we erase that portion and go into further discussion of that. We have to show that what, we have to show that gamma e equal to integration of e here c d mu or f d mu. Okay, in this way for all e belongs to this algebra we have to show that this one. Then we construct some gamma 0 e. Okay, and gamma 0 obviously we start from this algebra to 0 plus infinity. Okay, then what happened, this one equal to what, this one equal to gamma e difference this one integration of e g d mu, and obviously what we says about that, we known about that this one is less than equal to this one, so gamma 0 e obviously greater than equal to 0. Okay, since integration of e g d mu less than equal to gamma e. Okay, then what happened, then we have to show that what, we have to show that gamma 0 e equal to 0. Then we considered gamma 0 e greater than 0. Okay, we considered, and we also obtain what, gamma 0 e greater than 0. That means what happened, that means here gamma e greater than integration of e g d mu. Okay, this one happened. Okay, then again what happened, then we also see about that. Okay, see about that what, see about that this one is not hold. Okay, that means some contradiction occur. Why some contradiction occur, we also see about that, why some contradiction occur. Okay, that means this one hold, gamma e greater than integration of e g d mu. Okay, then okay, we also known about that. Okay, what happened, that means gamma 0 x greater than epsilon of mu x. Okay, we also that means since this one happened. Okay, that means gamma 0 difference epsilon of mu x, some for some epsilon greater than 0, for some epsilon greater than 0, this was we construct. Okay, then again what happened, since gamma 0 e greater than 0, okay, and mu be finite, then this one is happen. Now gamma 0 and epsilon mu, we erase that portion and going to further discussion of that. Gamma 0 and epsilon mu be measure, okay, be measure, we also known about that. Then since why gamma 0 measure, because gamma 0 we define here gamma 0 e equal to gamma e difference integration of e g d mu, okay. So this one is greater than equal to 0, so this one are measures, and mu is measure means gamma u mu is measure, okay. Now we're going to discuss on that what gamma 0 difference epsilon mu be a sign measure, be a sign measure, and sign measure, then what happened, if this one is sign measure, then some Han decomposition happen, and PNB Han decomposition, okay, Han decomposition for x with respect to sign measure, okay, gamma 0 difference epsilon mu and sign measure this one, then what happened, then we saw about that gamma 0 difference epsilon mu e intersection p obviously greater than equal to this one, that means p is some positive measure, then this one gamma 0 e intersection p greater than equal to epsilon mu e intersection p, okay. Then what happened, then we also going to further discussion of that, okay. We also this one happen, okay, and again we also see about that this one equal to what, this one equal to gamma of e intersection p difference what, difference e intersection p, okay, g d mu less greater than equal to epsilon mu e intersection p, okay. We write it in upper portion, okay, we erase that portion, and then what happened, then this one happened means we write it mu epsilon mu e intersection p, this one less than equal to gamma 0 equal to what, gamma e intersection p difference e intersection p g d mu, okay. Then this one equal to what, then this one equal to, we also says about that that means if some characters this one happen, then if some characteristics function gamma p characteristics function, okay, that means in p1 and other one is 0, so what we take g epsilon gamma p not psi p be characteristics function g epsilon psi p, okay. Then what happened, this one if characteristics function, then we know about that g is integrable and psi p characteristic function integrable, then this one are integrable, then we also see about that this d mu equal to what, equal to integration of e g d mu plus here epsilon mu, or we write another one psi p d mu, okay, e. Then what happened, then here integration e g d mu plus epsilon here psi p with respect to mu e intersection p, okay. Then what happened, this less than equal to e g d mu, okay, plus epsilon mu intersection p obviously greater than this one, okay. This one is we marked one time as this one, that means epsilon mu e, we write it here epsilon mu e intersection p less than equal to gamma 0 e intersection p, okay. So this one is happen, so what we get this one less than equal to, okay, here e g d mu plus gamma e. Okay, sorry, gamma 0 e. Okay, that means gamma 0 e intersection p, obviously less than equal to gamma 0 e. Okay, since e intersection p is subset of e, so this one equal to gamma e. Okay, so we get what we get, this one is less than equal to gamma e. Okay, then what happened, then g plus epsilon psi p belongs to this f. Okay, then integration of x g plus epsilon psi p, okay, d mu equal to what, equal to we get alpha plus epsilon mu p. Okay, and obviously greater than alpha. Here some contradiction. Okay, since we contradict what, because we know about that alpha equal to supremum of f belongs to this f integration f d mu. Okay, but here this one is not happen, so this one is then some contradiction occur. Okay, so what happened, so we have some problem. Okay, so we have some problem and we construct that therefore gamma 0 equal to 0, this implies gamma e equal to integration of e f d mu or g d mu. Okay, anyone, here g we construct, so g d mu, and for e belongs to this script. And now we also going to uniqueness, too easy. That means gamma e equal to, we will construct e h d mu. Okay, then integration h difference this d mu e equal to what, equal to, here this one is, that means h d mu difference h, this one g d mu equal to gamma e difference gamma e equal to 0. Okay, then what happened, then obviously g difference is equal to 0 mu almost everywhere on e, this implies g equal to h mu almost everywhere on e. Okay, this one is done. Then another thing is happen, what is needed there, that means if mu and gamma are sigma finite. Okay, we erase that portion and going to further discussion of that, what happened, what is need for there, that means if mu gamma are sigma finite, then what happens, then obviously some bn monotonically increasing sequence on descriptive. Okay, such that mu of bn less than plus infinity and gamma of bn less than plus infinity. Okay, for all n belongs to this natural number. Then what happened, then we obtain a measurable function hn, what x to 0 plus infinity with what, with h n x equal to 0. Okay, for x does not belongs to bn. Okay, so here gamma of e equal to integration of h n d mu. Okay, with respect to e. Then again we also see about that. Okay, what we see about that, some measurable functions, oh, sorry, h and x equal to this one and then this one. Okay, and then what we see about that, let m greater than equal to n, bm, so bm greater superset of bn. Okay, then integration of e hm d mu equal to integration of e h n d mu. Okay, this one mu almost everywhere on e subset of bn. Okay, then what happened for all m greater than equal to n? Here bm or pm you write as your wish. Then what happened? Then we talk about that gn equal to maximum of h1 h2 dot hn. Okay, then gn is monotonically increasing sequence, non-negative measurable function sequence. Okay, then gn is what? Gn is monotonically increasing non-negative measurable functions on x. Then what happened? Then gx equal to limit n tending to infinity gnx. Okay, then what happened here? For all x belongs to e equal to union of n equal to 1 to infinity e intersection bn. Okay, then this one is gamma e equal to integration of e g d mu. Okay, so we also see about that, and same portion for uniqueness. So uniqueness is too easy. Okay, so in this way we also develop this one. Okay, okay, so we also demonstrate how we prove Radon Nykodym theorem. So I think all I understand this portion. Okay, so if you have any that means problem, if you obviously talk about it, and if you get this type of video, please subscribe my channel. Okay, so uniqueness we will not prove here. Okay, similar way we prove uniqueness also. So this one is not right here. If we that means write uniqueness, then what happens? Then this way we also see about that. Okay, not a problem at all. This one is in this way. Here we talk about that gamma b sigma finite, and obviously what bn be a sequence, bn be a sequence x equal to union n equal to 1 to infinity bn, and bi intersection bj equal to phi. Okay, then what happened? Mu of bn less than plus infinity. Okay, for all n belongs to this natural number. Then mu is sigma phi, mu be sigma finite. Then what happened? Then gamma e equal to integration of h d mu of e. Okay, for all e belongs to this algebra script A, and integration of g difference h d mu equal to what? Integration of e intersection x g difference h d mu equal to what? Equal to integration of e intersection union of n equal to 1 to infinity bn g difference h d mu. Okay, equal to what? Equal to integration of E intersection of union of n equal to 1 to infinity bn g d mu difference integration of E intersection union of n equal to infinity bn h d mu. Okay, then this one equal to what? This one equal to gamma E difference gamma E equal to 0. Then this one equal to what? G equal to h mu almost everywhere on E. Okay, so done. So uniqueness is proved. Okay, so all are done. So in this way we also, that means if sigma finite, then also we discuss here. Okay, it's not a problem, too easily we handle this one. Okay, just we define some hn and hn x equal to, for all x does not belongs to bn, then this one is 0, and otherwise we define, then we also proceed. Okay, and proceed, we also going to gn equal to maximum of this, and gn is a monotonically increasing non-negative measurable function, so this one is happen. Okay, so gamma is equal to obviously integration of E g d mu. Okay, so this one is not a problem at all. This one also happen for sigma finite and finite. And if you get this type of video, please subscribe my channel. I think this one is the demonstration of Radon Nykodym theorem. Okay, we also discuss, and that means short wise. Okay, just understanding portion is that. Okay, so if you understand this type of, and if you get this type of video, please subscribe my channel, and if you want to give like, please give like, and if you had any comment, questions, suggestion, please write it in comment box. So today I stop here.